Welcome back to AI Unraveled, your daily briefing on the real-world business impact of AI. We're diving into the biggest problem plaguing long-running LLM deployments: context drift and brevity bias. Your models start strong, but they decay over time, demanding costly retraining and frustrating MLOps teams. Static prompt engineering is a dead end. Today, we're unlocking Agentic Context Engineering, or ACE, the future of production AI. Detailed in an essential article by the experts at Diztel, ACE is not just a better prompt, it's a fully operational system layer. It allows your LLMs to learn through adaptive memory and evolve instructions automatically, just like a human team member. But first, a word on reaching the right audience. Are you still marketing to the general public? Stop. Your platform solves the hardest challenge in tech: getting secure, compliant AI into production at scale. But are you reaching the right 1%? AI Unraveled is the single destination for senior enterprise leaders, CTOs, VPs of engineering, and MLOps heads who need production-ready solutions like yours. We have reserved a limited number of high-impact mid-roll ad spots. This is a direct line to your most valuable buyers. Don't wait for the competition. Secure your spot immediately by emailing us at info@dgamgatech.com. The real power of ACE is its core primitives: evaluation and self-reflection. Diztel's framework uses a generator, reflector, and curator pipeline to benchmark and auto-improve agents, giving MLOps teams a new governance layer and complete visibility into how context evolves. As Diztel puts it, ACE doesn't just prompt models. It teaches them how to remember, reflect, and evolve without retraining. If you're serious about scaling agents, this is the blueprint. That's all coming up right after the break, and you can read the full article at diztel.com.
So if you're using today's large language models, maybe fine-tuning one for work, or even just getting help with some code, you pretty quickly hit this wall, right?
Right.
They're amazing, truly brilliant, but they just don't learn as they go.
Exactly. They're incredibly powerful, but they're kind of frozen in time. The
Yeah.
PPT or Claude you interact with, it's essentially the same model it was the moment its, massive initial training finished months ago.
Right. Use it 100 times,
Mm.
it makes the same mistake 100 times.
Mm.
It never adapts. It just forgets every single time.
It forgets, and that's the real crux of the issue.
And if you, the user, actually want that system to get better, to say, learn a new company rule, or stop making that one specific error in your process, well, that becomes this huge effort. You basically have to rebuild it.
You do. You're talking about fine-tuning, maybe even retraining the whole neural network. And that's slow. It needs massive compute power, constant human oversight, labeling data. It's just
Yeah, it's expensive.
the cost, the overhead. It makes this idea of continuous real-world AI adaptation almost impossible for most companies.
It feels unsustainable.
Mm-hmm.
But the research we looked at today points to something different, a framework that might actually change this whole dynamic.
Yeah.
It's from Stanford, and they call it Agentic Context Engineering, ACE for short.
AC, yeah. It's presented as this potential path towards genuinely self-improving AI. It feels like a paradigm shift, moving away from the AI as just a static tool, very smart responder.
To something more like an adaptive agent, one that learns as it goes.
Precisely. It sort of cuts the Gordian knot. It separates the really costly part, training the model's core intelligence, from the much cheaper, faster process of just improving its working memory and skills over time.
Okay, let's unpack this then. This deep dive is really about understanding how ACE pulls this off, how instead of constantly rebuilding the AI's brain, it focuses on building this smarter, evolving memory. Our mission here is to get into the mechanics, see how it transforms the AI from that static tool into, well, an adaptive collaborator for you. So if we're not messing with the expensive core model, the neural weights and all that, what exactly is the mechanism here? How does ACE actually enable this self-improvement?
Well, ACE works by focusing on and refining the context the LLM uses, not changing its internal parameters, its fundamental wiring. Think of it less like boosting the AI's raw IQ and more like giving it this incredibly efficient, personalized memory system, a system that it actually writes and manages itself.
Okay, so we're not doing brain surgery. We're just giving the brain much better notes, and these notes are constantly being updated.
But that's a great way to put it, yeah. The analogy the researchers use is giving the AI a living playbook. It might start simple, just definite instructions.
Right.
But as the AI does tasks, maybe runs into problems, or even finds a really clever shortcut, that playbook dynamically grows. It gets richer, smarter, and crucially, it gets better aligned with the actual tasks it's performing in the real world.
I like that living playbook idea, because living implies it's active, right? Not just passive storage. But okay, if the AI is writing its own notes, how do you stop that playbook from just becoming a huge mess, like a junk drawer of random, maybe even conflicting information?
And that's where the structure of the ACU architecture comes in. It's clever. It doesn't just have one part doing everything. It splits the learning into 3 specialized roles or pillars that manage this learning loop. That structure is key to keeping it organized and effective.
Okay, 3 pillars. Tell us about those.
All right. First, you've got the generator. This is the workhorse, basically. It does the task you ask it to do, write code, analyze a report, whatever. But critically, it also outputs its reasoning, like showing its work, how it got to the answer.
Okay, so we have the output and we have the how. But how does the system know if the how was any good or if the output was successful? That feedback seems crucial.
Exactly. And that's the second pillar, the reflector. Think of the reflector as the quality control, the critical reviewer. Its job is specifically to look at the generator's output and its reasoning trace. It figures out where things went wrong or maybe where things could have been done better, more efficiently. And then, importantly, it distills that down into a concise, transferable lesson. Not just fixing the one instance, but finding the general principle.
Why have a separate reflector, though? Couldn't the generator just evaluate itself?
It's really about perspective and generalization. The generator is focused on getting this task done right now. The reflector steps back. It looks for patterns, for systemic issues. It extracts those higher level rules.
Yeah.
So if the generator keeps failing because of, say, a specific dependency issue in coding, the reflector doesn't just flag that one error. It might create a general rule like, hey, when dealing with this kind of dependency, always check version compatibility first. It provides that systemic view.
Got it. So it finds the general lesson. And once you have that insight, that new rule, it needs to stick around. It needs to become part of the permanent knowledge.
And that leads us straight to the third pillar, the curator. The curator is like the editor and librarian for the playbook. It takes that polished, high-level lesson from the reflector and carefully integrates it into the AI's evolving context, into that living playbook.
Okay.
It makes sure the useful insights are preserved so the AI builds on past learning. But it also prunes things, maybe removes redundant rules or outdated information to keep the playbook efficient and prevent it from getting bloated.
So the key mechanism here seems to be these incremental context updates. It's not rewriting the whole playbook every time it learns something tiny. It's adding small, precise updates that build up, that lets it learn continuously without just forgetting what it knew before.
Exactly right. That targeted incremental update process managed by these specialized components is really the engine driving this adaptive intelligence.
And this whole structure sounds like it's designed specifically to overcome the problems with how LLMs work now, what the source is called static context. Can you remind us why relying only on static context is such a limitation?
Yeah, static context is inherently temporary. When you talk to a standard LLM, your instructions, the conversation history, it's all treated as input for that specific session. Then, poof, it's gone. It gets purged.
Right.
So if you want the model to improve, it falls entirely on you, the human. You become the prompt engineer, constantly crafting better, more detailed instructions for every single interaction, trying to give it the context it forgot.
But that manual approach, trying to constantly feed it the right context, it hits these walls. The sources call them the 2 biggest killers of long-running AI performance.
Oh, they absolutely are. The first one is brevity bias. It's just human nature, really. When we manually refine a prompt over time, what starts as maybe a detailed, careful instruction, we tend to shorten it, compress it. We simplify for convenience.
Yeah, I can see that. It's like the analogy they used in the novel editor. Imagine writing a book, and every morning your editor deletes half of yesterday's chapter just to save space.
Exactly. Crucial details just vanish. The AI's output gets shallower, it loses nuance, because that essential scaffolding, that detailed context, keeps getting chipped away by our own attempt to be efficient.
And the second killer, context collapse. This is almost the opposite problem, right? We try to fight brevity bias by just cramming everything into the prompt.
Right. You pile on instructions, history, examples, notes, trying to give the model everything it might possibly need. But the context window isn't infinite. Eventually, you overload it. The model starts effectively overwriting or just ignoring older but still critical information buried deep in that massive prompt. It's like that image of stacking too many sticky notes eventually. The bottom ones just fall off, ignored. The model can only really focus on the most recent stuff.
Honestly, who hasn't done that? You scroll back up in a long chat history trying to find that key instruction from an hour ago, and you realize the AI seems to have totally forgotten it. It feels like a very human limitation, but it's baked into the current AI design.
And ACE is designed as a systemic fix for both. It tackles brevity bias and context collapse head-on. By having the curator manage this structured, evolving playbook, the AI accumulates useful knowledge in a dense, high-quality format. It doesn't suffer from that constant human-driven compression or just random overload.
So the goal is that the AI actually becomes more knowledgeable, more context-aware, the longer it works, not less.
Precisely. That's the core idea.
Okay, let's make this more concrete. Theory is great, but how does this shift from a reactive tool to an adaptive agent actually look in practice? The Python script example from the sources seems like a good illustration.
Yeah, it's a really clear one. So imagine you have an ACE agent, and its task is to automate some file processing using a Python script for a user. The generator writes the code.
Okay.
But, the script fails. Why? Because it hard-coded a file path like C users Bob instead of using a method that works for any user's directory.
Right. So in the old way, with a standard LLM, the system just stops. It failed. And you, the developer, have to go back, figure out the error, and then manually update your prompt. Hey, AI, next time, please use variable paths like os.path.expandisr.
Exactly. You have to explicitly teach it again. But with the ACE agent, this failure triggers the learning loop. The generator produced the faulty code in its reasoning. The reflector sees the failure, analyzes why, and diagnoses the systemic mistake, hard-coded path. Then, the reflector extracts that general lesson. Okay, when dealing with user directories in Python, the best practice is always use the os.path.expandisr function.
And that specific rule, use os.path.expandisr. That's not just a one-off correction. The curator takes that lesson
And adds it to the living playbook. It becomes a permanent piece of the agent's knowledge about writing good Python code.
So the crucial difference is the outcome next time.
Exactly. The next time this ACE agent gets a similar coding task involving user files, it just automatically applies that os.path.expandisr function. Nobody needs to remind it in the prompt. It has genuinely learned and integrated a coding best practice through its own mistake and reflection.
That really is a fundamental shift. The AI stops being this static thing you have to constantly guide with detailed prompts where we do all the learning and refining.
Right.
And it starts acting more like a collaborator that gets better on its own. ACE basically automates that whole painful cycle of prompt engineering and capturing lessons learned. It builds it into the system itself.
Yeah, if you compare them side by side, the difference is stark. Your traditional prompt-engineered LLM, its learning is static, its context is temporary just for the session. You're essentially renting its intelligence one query at a time.
Whereas these ACE-enabled agents, the learning is described as continuous and reflective, and the context is persistent and evolving. It builds over time.
And that difference flows directly to the cost. Improving a traditional model, that cost is high. You need those big, expensive retraining or fine-tuning cycles.
Right.
With ACE. The improvement cost is potentially very low. Learning happens through these tiny, computationally cheap, incremental updates to the context playbook. The system gets smarter simply through being used, not through massive new investment.
It reframes intelligence, doesn't it? Not as just this fixed capability you train once, but as this dynamic process of adaptation through use. Okay, but let's talk results. Concepts are nice, but did it actually work? What did the Stanford experiments show in terms of measurable data?
The numbers they reported are pretty striking. First, efficiency. ACE apparently reduced adaptation latency, basically, how long it takes the model to learn and apply a new lesson by over 80%. That kind of speed up could drastically change how quickly AI systems can adapt in the real world.
Wow, an 80% reduction in learning time. That's huge for development cycles. Did that speed translate into actually performing tasks better?
It seems so. On standard benchmark tests for AI agents, they saw results improve by about 10.6% overall.
Okay.
And maybe even more interestingly, for more specialized, complex areas like financial reasoning tasks, the improvement was around 8.6%.
That 8.6% in financial reasoning is definitely noteworthy. That's often where subtle context and careful logic are absolutely critical and where models can easily stumble.
And maybe the kicker from an economic perspective, they demonstrated that this performance boost was significant enough that ACE, running on smaller open source models, could actually achieve results rivaling much larger, more expensive models like GPT-4.
So you could potentially get near top-tier performance without paying for the absolute biggest, most resource-hungry proprietary models.
That seems to be the implication. It opens the door to high performance with lower costs and potentially more control using open source alternatives.
Now, besides performance and cost, there's another angle that's really critical, especially for businesses: transparency, control, governance. How does ACE deal with the black box problem, the fact that we often don't know why an AI makes the decisions it does?
That's actually one of the most compelling aspects because all the learning, all the adaptation is stored right there in that living playbook as these human readable entries like bullets or rules. The entire evolution of the model's behavior becomes auditable. You can actually see why it changed its approach.
That is huge, because when you fine-tune a regular model, the changes are spread across billions of internal numbers, right?
Right.
You see the output change, but you have no clear idea why.
Exactly. With ACE, if the AI suddenly starts handling file paths differently, you can literally open the playbook, find the rule added by the curator, like the os.path.expand user example, and know precisely why that change occurred.
So it makes the systems learning process interpretable. You could track it, manage it, maybe even roll back specific learned behaviors if needed.
Potentially, yes. It allows the AI's evolving knowledge to be integrated into standard MLOps pipelines. You get visibility, you get control. It offers a level of safety and compliance oversight that's just missing when you're dealing with opaque, retrained models.
Okay, so pulling this all together, what's the big picture takeaway here? ATE seems to fundamentally decouple the evolution of knowledge from the very expensive process of retraining the core model. It potentially makes AI development faster, safer, and maybe more sustainable for long-term real-world use.
I think that's right. It offers a plausible path towards AI systems that can genuinely get better based on feedback from the real world they operate in. Think about automated customer service or systems navigating complex rules in finance or healthcare. They wouldn't need to wait for these massive, infrequent retraining cycles to adapt.
Or even just thinking about a personal AI assistant. Imagine one that doesn't just answer your questions, but actually adapts day by day, learning from your interactions, your successes, your corrections, getting better tuned to your specific needs, your writing style, your projects.
Yeah, an assistant that gets genuinely smarter for you the more you use it. It builds up this personalized understanding, that ability to kind of automatically bridge the gap between today's smart but static AI and tomorrow's truly adaptive self-learning systems. That feels like the core promise here.
It really makes you think. The last decade in AI felt defined by this race to build bigger and bigger models. Maybe the next decade is about teaching these models how to learn effectively on their own, quickly, efficiently, and transparently.
Which leaves a really interesting question for you, the listener, as this kind of technology potentially moves forward. It seems the question isn't really, can AI learn anymore? It's becoming, how soon will my AI start learning all by itself?
That's it for today's deep dive. We hope you walked away with actionable insights for your enterprise strategy. Before you go, let me remind you of the unparalleled value of this platform. AI Unraveled delivers deep, uncompromised technical insight that keeps our audience, senior enterprise leaders, tuned in to the very last minute. That sustained attention is the best place for your ad. This is your opportunity for a direct line to your most valuable buyers, the CTOs, VPs of engineering, and MLOps heads who sign off on high-stakes infrastructure. Stop wasting budget on general marketing noise. Secure your high-impact premium ad campaign right here. Email us today to reserve your mid-roll package, info@djamgatech.com. Thank you for listening to AI Unraveled. We'll be back tomorrow with more.